All right, let's begin. So today we'll be covering the revision for quants. We've planned to cover it across 2 lectures, but if possible, then we'll cover entire quants mind maps today itself. So for quants, we'll take the mind maps specific to the chapters for the first half. So first chapter we have is rates and returns. The rates and returns topic firstly has a discussion of opportunity cost. Opportunity cost is denoted with the symbol R. Throughout our syllabus, we refer to this concept as interest rate, required rate of return, cost of capital, cost of equity if we are talking about equity securities, cost of debt if we are talking about bonds or any other such securities. So this is a concept that is repeated all throughout the syllabus. Now over here, we represent this rate as real risk-free rate plus inflation plus risk premiums. Whenever you invest in a security, you will be taking up some amount of risk. So as you take more and more risk, the expectation of your return will go up. So risk premium is how much return you need to be able to take the risk. Then we have some basic calculations. For calculating the rate of return itself. Here, firstly, we cover arithmetic mean, which is simply sum of returns divided by number of years. Then we also cover geometric mean, which is 1 plus R1, 1 plus R2, so on all the way till Rn, root minus 1. And third similar calculation we have is harmonic mean. Harmonic mean is not used to calculate returns. It is used to calculate average prices. So price averaging or cost averaging, that is where we use it. So it is n divided by sum of 1 upon observations. So mostly this will be used when you are investing in a security for multiple months where the share price is changing. So only those kind of questions can be tested via harmonic mean. Now the questions that you get for harmonic mean, you can also solve them with just pure logic in your exam. You don't need to cram the formula for this. So if you're comfortable with the logic based approach for calculation, you can stick with that. No need to worry about the formula. Apart from this, we have holding period return. Holding period return is ending value minus beginning value adjusted for any cash flows. This could be any income which is arriving from this particular security and divided by the amount you invested. Holding period return is the only rate in our entire syllabus which is not per annum. We will never interpret this as a per annum rate. This is the rate for whatever your investment horizon was. So if you invested for 3 months, this is 3-month rate. If you invested for 5 days, this is 5-day rate. But since securities in the market quote an annualized rate, to make this comparable with all the other securities, we calculate effective annual yield or annualized rate of return. So this is calculated simply as 1 plus holding period rate adjusted for time minus 1, where this time would either be 365 by days if your investment horizon is given in the form of days, or it would be 12 upon months if your investment horizon is given in the form of months. Now, EAY, when we cover the prerequisites of time value of money, we cover the concept of effective annual rate over there also. Plus, this is more of a conceptual topic. The more you try to just cram this equation, the more chances are that institute can rearrange the information of question and confuse you. So instead of cramming the formula, understand the logic which is driving this formula. Periodic rate adjusted for 1 year worth of time period. So sometimes you can get questions where you're first investing somewhere for 3 months, then you follow it up with a 2-month investment, then you follow it up with 5 more months of investment, and now you have to calculate annualized return. So you should be able to apply the logic of this formula in multiple situations. So if you cram the formula, Institute has many ways to confuse you. So instead of cramming the formula, focus on the logic behind it. Then second half was a few advanced calculations. This is where we cover time weighted return, money weighted return. Time weighted return is simply geometric mean of individual rate of returns for different years. Money weighted return is IRR. You calculate the cash flows, you plug the values in, and this gives you the return. Then this is where you also cover continuous compounding. So for this, future value is calculated as PV e to the power RT, or the second formula, more useful when you have to calculate rate or time, where all the other details are given, but the question is asking you to calculate rate or time. And the first formula is more suitable when you have to actually calculate present value or future value. Continuous compounding, even though it is mentioned in Quants, it can be tested in your entire syllabus. You can get questions in fixed income, in derivatives, in equity. We just put a small word at the end of the question, rate 10% or something, as per continuous compounding. So don't restrict yourself to thinking that this is only for quants. In fixed income, if you get a question like this for zero coupon bond, then in fixed income also what we do is 1 plus rate to time. Instead of that, e to the power RT. So you should be able to apply continuous compounding for all the securities, not just restricted to this calculation. Lastly, this chapter had some miscellaneous terms. Real versus nominal return. Pre-tax versus after-tax return. Gross versus net return. So difference in gross and net is simply of fees. Gross return is return after you subtract all the transaction cost. Net return is your return after you subtract transaction cost as well as fees. So transaction cost, brokerage commission that you pay, that is not differentiating these two. The difference is only management fees. Real and nominal, the difference is primarily inflation, and pre-tax, after-tax, the difference is taxation. Apart from this, we cover the topic leveraged return here. Leveraged return, they've given a complicated formula in your books for all the topics. This is again a topic which can be tested in any of the chapters. So easiest way of solving it is to compare that formula with the holding period return itself. The numerator for leveraged return will be exactly same, ending value minus beginning value plus minus any cash flows. Now, leveraged return means you have invested money after borrowing some amount. So if you have borrowed some amount, you will have to pay interest on it. So your numerator is basically holding period return after the effect of interest. Denominator would be your investment. So not actually beginning amount, but out of that beginning amount, how much you invested from your own pocket. So if the book formulas feel technical because they have some rigid notations, the easier approach would be that you simply remember this and solve it logically. Leverage return is nothing but holding period return, where denominator is your money invested and numerator will always have interest on loan. Any doubts or queries with this first chapter?
सर
Yes.
लेवरेज रिटर्न में कैश फ्लो में वेरिएशन मार्जिन या फिर मेंटेनेंस मार्जिन है ना?
नहीं, this is same cash flow as we have in holding period return. So let's say any dividend or coupon can come here. That is the same amount over here. This is cash flow from the security. All right. The second chapter we covered was data. For this topic, we split our discussion into two halves. And then apart from these two halves, your books have a few extra miscellaneous topics. The discussion is measures of central tendency, and measures of dispersion. For measures of central tendency, we have calculation of mean. Because most of these formulas are same as the one we've just written in the previous chapter, you simply need to know the type of calculations. Arithmetic mean, geometric mean, harmonic mean, and weighted average. So different ways in which mean can be calculated. Apart from this, we had trimmed mean, which is a variation of arithmetic mean. The problem with arithmetic mean is that it gets affected by the outliers. So to deal with that problem, trimmed mean eliminates the outliers. You solve as if there is no outlier. And then the second one is Winsorized mean. This one replaces the outliers with an acceptable value. That acceptable value in real world would often be found out by way of confidence intervals. So our high or low value, which is acceptable, would be the starting or end points of what? Confidence interval.
सर ये कौन से चैप्टर में था? कॉन्फिडेंस इंटरवल ऐसे हमने करा था.
Confidence interval we covered in the topic sampling and inference.
Okay.
हाँ जी, अगस्त एग्जाम वाले स्टूडेंट्स अगर आ रहे हैं रिवीजन के लिए तो रिवाइज करके आएंगे. Then we had median. Median is the central value of an arranged data set. For the purpose of CFA, we always arrange in ascending order because we are not just calculating median. We'll also be calculating quartile, decile, percentile, all of those extensions. So this is n plus 1 by 2th observation. Median formula, whether it is for median or for any of its extensions, all the formulas don't tell us the final answer. They simply tell us the location of the answer. So final answer, you'll then have to calculate by observing the data. So we did this. We covered quartile, quintile, decile, and percentile. Along with this, we also covered a method known as linear interpolation. This method can be tested anywhere in your syllabus. Matrix pricing also uses the concept of linear interpolation, where if rates are given at two different maturities, you find out your required rate in matrix pricing using this approach. So this is a mathematical technique for calculation. And the third is mode, which is value with highest frequency. The value which is repeating most often. We can have more than one model values in our entire data set. No need to average them out. Then we have dispersion, first calculation is range, maximum minus minimum value within a data set. Then we had mean absolute deviation. This is sum of absolute deviations from mean divided by number of observations. And third is standard deviation. Square of deviations upon n minus 1 whole root. Now, over here, we also had an extra discussion regarding population deviation and sample deviation. If you get a question asking you to calculate just the standard deviation, your default calculation is always supposed to be sample. But in all of the later topics where we use standard deviation as an input to calculate something further, over there you'll have to remember whether the formula uses population deviation or sample. So in all the future topics, you'll have to be careful which deviation you're using. But if you get a question asking just to calculate standard deviation, it is always sample. Apart from this, we had an extra discussion regarding covariance and correlation. Both are measurements of how related two variables are. Covariance simply tells me the direction of relation, plus or minus, moving in the same direction or opposite. Correlation tells me strength as well as direction of relation. So it's an improvement over covariance. Now, for the purpose of exam, you only need one formula. Covariance of xy is equal to deviation of x, deviation of y, and correlation of xy. This is correlation. This is the only formula you need because in your calculators, all three values will be available directly. So you don't need to bother with any manual formula to calculate correlation. You also don't need to bother with any manual formula to calculate covariance. This formula is sufficient enough for all exam related calculations. Any doubts with this topic? All right. Now, in your quants books, this is reading number 3. All right. The actual name is Statistical Measures of Returns. So, this is reading 3. The previous flowchart was for reading 1. Reading 2 doesn't need any study at all. If you guys have done your study of fixed income equity derivatives, reading 2, you can straight away jump in and practice questions. You don't need to worry about reading through chapter 2 at all. Skip it, just start practicing questions once you're done with the rest of syllabus. Third topic, probabilities. Probabilities topic, this is broken into 4 sections. Firstly, we have some basic introduction where we focus on the meaning of probability, what are odds, how to convert from odds to probability and probability to odds, and types of probability. 3 types of probabilities exist: empirical, where you calculate probability using historical data; priori, where you calculate probabilities using logical reasoning; and subjective, which is purely guesswork, your intuition. Now, apart from these rules, we move to second part, which is rules of probability. 3 rules were covered. First is addition rule, which looks at probability of either A event happening or B. Any one of the 2 events happening will be considered as a successful outcomes. So this is probability of A plus probability of B minus joint probability. This is how we write A and B, joint probability. Second is multiplication rule. which is A and B. So this is denoted as probability of A given B into probability of B, or simply probability of A into probability of B, depending upon whether A and B are independent events or dependent events. If A and B are independent, then we use the second notation, independent events. And if A and B are dependent events, then they need to happen in sequence. So how do you read this? A given B. So first B has to happen and then A has to happen. The events will happen in a sequence if they are dependent. And third rule is total probability rule, which is simply calculating the unconditional probability of any given outcome. If I just want to calculate probability of A, that is total probability rule. So this is calculated as probability of A given B into B plus probability of A given not B into not B. So what are the chances A will happen when B is happening? And what are the chances A will happen when B is not happening? If I add both of these up, that tells me what are the total chances of event A actually happening. Now, these three rules then get applied in the concept Bayes theorem. You can solve it using the tree diagram approach, where you approach the entire question in a logical manner, simply draw out a tree to visualize all the information, and then you do the calculations logically. The other approach is a formula-based approach, where probability of B given A is calculated as probability of A given B denominator is total probability rule and numerator is multiplication rule. So it is up to you which approach you find more comfortable. My suggestion would be you follow the tree diagram approach, because sometimes institute has been known to give you questions where you don't have two events A and B, you have three events. So sometimes the tree you make may have three nodes and then two nodes for each of them. So then you have 6 outcomes. So in those situations, the formula is something which often becomes a little tricky to understand. So tree approach, more easy to implement and also high chance that you will get the answer correct in the first try. So Bayes theorem is where your actual course syllabus starts from. Very likely that you will get at least one, maybe even two questions just from Bayes theorem in the exam. Lastly, we had an extra discussion of probability based statistics. So this is where we covered a small shortcut so that we can solve all probability based questions also to calculate mean, standard deviation, covariance using the calculator. The shortcut was, if probability in multiples of 10 or 5, repeat observations accordingly. So if you have probabilities given in multiples of 5, you will have total of 20 values to enter in your calculator. And if probabilities are in multiples of 10, then you have 10 values to enter in the calculator. And then you solve the question just like you normally would. So all you have to do here is to simply repeat the values when you feed the data in the calculator. So if something has 30% probability, repeat it 3 times. For every 10%, you repeat it once. If your multiples are of, let's say, 5% each, and something has a probability of 35%. 35% is 7 times 5. So you repeat the value 7 times. So you'll have to observe whether probability is multiples of 5 or 10. and accordingly you'll have to repeat the values in your calculator. So just a small adjustment in your data entry. Beyond that, normal solution like you get in the previous chapters. All right. Last discussion that we take up for the first half of quants is portfolio mathematics. So here, two values that you should be comfortable in calculating. One is return of portfolio, which is simply weighted average. And you can extend this formula for as many securities as you have. The second calculation is portfolio risk. For this, if you have a two security portfolio, then it is weight of A square, risk of A square. Whole root. Most of the times, this is the formula that you'll be using, but there is one unique kind of question that you get where you have covariance matrix given. In those kind of questions, a three security portfolio is also possible to be tested. This testable via covariance matrix. You won't get a situation where directly data for A, B, and C is given because your calculator is only capable of having two data series at a given point of time. So if institute wants to give you actual data for security A and B, they'll give you the two security portfolio. The three security is only testable if covariance matrix is given. And for covariance matrix, the one thing you have to remember is covariance of X with itself is simply variance of X. Remember this. This will help you solve the questions using covariance matrix. Any doubts till this topic?
पर इसमें सेफ्टी फर्स्ट रेशियो की वो क्या होती है?
सेफ्टी फर्स्ट रेशियो जो हम आगे Z क्रिटिकल वैल्यू करेंगे वो वही है. We'll write it in the next flow chart.
सर जो टारगेट डाउनसाइड डेविएशन का फॉर्मूला था उसमें हम एन टोटल लेते हैं और डेविएशन सिर्फ नेगेटिव वाली काउंट करते हैं.
Yes. But in that, the denominator would be n minus 1. N is total observations, but your numerator will only be the negative deviations.
ओके सर.
All right. Now, beyond this, we had one entire discussion purely focused on a prerequisite topic, which was probability distributions. Now, we don't need flowchart for all of that topic, but we do take a small flowchart for normal distribution. We had two discussions for normal distribution. First was the features. The features are, it is completely defined by mean and standard deviation. It is symmetrical across mean, median and mode will be same. Zero skewness and 3 kurtosis. Kurtosis refers to the peak and tails of the distribution. So both of these terms are used for shape of distribution. Kurtosis focuses on how tall the peak is and how fat the tail is. Skewness focuses on biasedness of data, whether data is biased on the higher side or lower side. And the name of skewness is given as per position of outliers. If outliers are on the positive side, we call it positively skewed. And if the outliers are on the negative side, we call it negatively skewed. So we covered all the features. Now for skewness, you should also be able to identify positive and negative skewness based on mean, median and mode. So in positive skewness, mean will be the highest value, mode will be the lowest value. And in negative skewness, it would be exact opposite. Just remember one thing, mean is the value out of these three affected by outlier. So positive skewness has positive outliers, mean will be highest value. Negative skewness has negative outliers, mean will be the lowest value. So based on these three, sometimes you can also get question where numbers are given and you have to identify what sort of skewness are we looking at. So in those rare questions, you calculate all three. If they are equal, we're looking at normal distribution. If they are not equal, then based on which is higher, you can decide whether it is positively skewed or negatively skewed. Now, apart from these features, it also extends from minus infinite to plus infinite. Apart from this, we had calculation of probability that we covered. हाँ जी.
इसमें फॉर्मूला लिखा है स्क्यूनेस का
हाँ.
वो relevant
Not relevant. Mainly for you to understand why 0 will come. Because in that formula, you have power 3. So positive and negative will cancel each other out. So when we have skewness 0, it means you're getting a perfect symmetry where positive outliers and negative are cancelling each other out. So formula was just for that reference so that you know what the 0 is. Chances of you getting numericals based on the formula, very remote. Then calculation of probability using the normal distribution. So over here, first you calculate Z critical value. Z critical value is calculated as mu minus mean upon standard deviation. Now, those of you who may be confused, this is the same formula for Roy's safety first ratio. We have mean, we have a threshold level of return, the minimum return you need. So instead of mu, we use minimum return required and we use portfolio risk, portfolio returns. So Roy's safety first ratio is nothing but an application of this formula. And shortfall risk is the probability that your actual returns will fall less than the threshold. So if Roy's safety first ratio on distribution is telling you the Z critical value of this point, shortfall risk is this area below. So like we do with normal distribution with graph, we should be able to calculate distance. And once we have the distance, we look at the Z table to calculate probability. The application of these two steps is Roy's safety first ratio and shortfall risk. So this probability is what we call shortfall risk. So calculate Z critical value, and second is check probability from Z table. For Z table, how do you check probability? It's a straightforward process. Till first decimal, you look at first column, and second decimal, you look in the top row. So whatever Z critical you are getting, you first have to round it off to 2 decimals and then check the value from the table. If you get a question like this, institute will have to provide you with the table. But as we cover further topics of our syllabus, there are certain values of Z critical or certain values of probability where table will not be given. Those you have to remember. So those are referred to as level of significance 1%, 5% and 10%. So at those 3 points, don't expect table. But for any other point, institute will provide you with the table. Any doubts with normal distribution? Tanish, coefficient of variation can also be used to calculate safety first ratio. Coefficient of variation is standard deviation upon mean. So you can, if you do a reciprocal of this Z critical value, you will get a value which will look similar. You will have standard deviation in the numerator, mean in the denominator. Tanish, yes. Higher the ratio, lower the shortfall risk will be. Because as your ratio increases, the area left on the lower side, it will start to fall. So less and less chance of you having returns less than your threshold level. All right. So beyond this, we had a discussion regarding sampling. In this topic, first we start with the discussion of methods of sampling. We can have random sampling, where you collect data at random. You can have systematic sampling, where data is still collected at random, but the process of collection has a system to it. So basically, selection of data will be done as per a predetermined approach. So maybe every 5th value is selected or every 10th value is selected. So now selection is no longer the problem for researchers. Selection is automated, but otherwise the sampling is still random. Then we have stratified sampling, where we wish to capture the characteristics of population in terms of classification. So let's say I'm looking at some data and I am looking at some customer survey. So we have male population, female. So if my customers comprise 70% of male population and 30% female, then I would prefer in my sample also I capture that 70-30 ratio. If I want to capture this across multiple groups, subgroups, categories, then we call it clustered sampling, where you do the stratification at various levels. Apart from this, judgmental sampling, where we let the researcher decide what data should be part of the sample. Followed up by convenience sampling, where we pick the data which is most easily available to be part of my sample. So whichever data is most convenient to capture, to gather, that becomes part of my sample. Now beyond this, we had central limit theorem. Theory topic, but very critical, very important. Central limit theorem says in sampling distribution. So you should know the meaning of sampling distribution. It is a collection of mean calculated from small samples picked from same population. So from one large population, you pick out many small samples. Each sample you calculate the mean, you combine all of them together, that calls sampling distribution. So in sampling distribution, as the sample size increases, mean becomes roughly same as population mean. This is your closest approximation that you can mathematically get to population mean. Your standard deviation, also known as standard error. This becomes standard deviation from the raw data divided by root of n, either sample or population. And lastly, distribution approaches normal. So the shape of distribution starts to appear similar to a normal distribution. This means you can use Z table or T table to actually study this data set. This will happen when your sample size is starting to get large enough, 30 or more. Then based on this, we had a calculation topic, confidence interval. Confidence interval can be calculated in 3 different variations. So most basic calculation is mean plus minus Z critical into standard deviation. This is what you will use if a single data set is provided to you. If you're dealing with a sampling distribution, then Z critical multiplied by standard error. And if, let's say, population deviation is not known, then we will use mean plus minus Z critical upon standard error calculated, sorry, T critical, not Z. T critical into standard error calculated using sample standard deviation. Lastly, we had a few miscellaneous terms, specifically resampling, which is the process of creating multiple samples from a limited amount of data. So here we covered 2 techniques. One is bootstrap, where you create multiple samples by replacing one value from your existing sample. So every time you simply replace one value, what is left, that becomes a new sample. This can be calculated using the formula for combination. Then we have an easier technique, jackknife. It is easy to implement because every time you simply remove one value from your old sample to create a new sample. Jackknife technique is easy to implement, but it is not computationally as accurate. Bootstrap is more accurate, but it is computationally demanding. Apart from this, some biases that can happen in the process of collection of sample, those also you should be aware of. The idea is, if my sample itself is not correctly capturing the data, it is not collected in the correct manner, it is possible that all the interpretations I draw from such a sample will lead me to wrong conclusions. So idea is, I want to make sure my sample correction process itself is free from biases. Any doubts or queries with this? All right. So data analysis can be done in 3 ways. One is sensitivity analysis, where you change the value of one input. So let's say you create a financial model for valuation of a company. Now that model will have inputs in the form of growth rate, in the form of dividends, cash flows, profits, whatever you're using to do the discounting process. So if you change one input at a time to see that if I change growth by 1%, then how much my value will be affected, that is called sensitivity analysis. It is good to study which inputs are very sensitive, which are more relevant for my analysis, but the problem is it is not very realistic. If we take economic analysis, I may have inflation, unemployment, interest rates, forex rates, multiple factors. One of them will not change in isolation. It is not possible in real world that inflation goes up, but everything else remains the same. So sensitivity analysis is good for internally assessing the model, but it is not very practical. To make it practical, we switch to scenario analysis. Over there, we change all the inputs to represent a scenario. So if I'm talking about economy, maybe best case scenario is we have low inflation, low unemployment, reasonable interest rates, forex rates are also in favor of the country. So this would be a best case scenario. So I'm changing all the inputs, but I'm not changing them randomly. I'm changing them in a logically correct manner so that they represent a particular economic scenario. In the worst case scenario, very bad recession, inflation will be high, unemployment will be high. So now I'm changing all the inputs, but in a manner that they together represent an economic scenario. That is called scenario analysis. In scenario analysis, the researcher will create 2, 3, 4, 5 scenarios of what he thinks can happen in the real world. Simulation is basically automation of scenario creation. So researcher would create 4 or 5 scenarios. In simulation, I will let the software create as many scenarios as possible. So we are no longer talking about scenarios which are realistic or which are likely to happen. Any and every scenario which possibly can be created will be studied by the software. So simulation is just a addition on top of scenario that we will create as many number of scenarios as we need to cover as many possibilities as possible. All right then. So if there are no doubts, then we are left with 2 mind maps. First is hypothesis. Hypothesis and regression, you can expect about 3-4 questions to come from these topics, but these are going to be relatively easier questions. It has been observed from student feedback also and otherwise also that institute prefers to give easier questions from tougher topics, and they prefer to use tricky language in easier questions. So whatever concept is mathematically easy, the institute will try to confuse you by giving you extra information, by giving you some technical language. But when a concept itself is tough, often institute will give you straightforward questions. The idea is institute simply wants to reward the students who are actually putting in the effort to study the tougher topics. Because a lot of students, by the time they get to hypothesis regression, they decide to simply leave this topic. So if you just study it, have a basic understanding of what the concept is, there is a very good chance you will score in questions where a lot of other candidates would simply not be able to attempt the question. So this is very critical topics for making sure that you clear the exam. For hypothesis, the best mind map would be in our class notes where we took a proper table of 5 different types of hypothesis. So we'll just draw a mind map by rearranging all that information itself. So hypothesis is simply testing a claim using data. Throughout our syllabus, we have 2 major discussions. One is test of single mean, where a statement or a claim is made about the returns of a single security. In this case, you can perform the test in 2 ways. One is using the confidence interval approach and the other is using a test statistic approach. So for test of single mean, first thing you should know is null and alternate, how to construct and what they represent. These are 2 mutually exclusive and exhaustive statements. The idea is if you prove one is correct, the other is automatically proven to be incorrect. That is why we don't need to perform test twice. We perform the test on one and we can draw the conclusion for both. How to construct them? Simple rule is if there is a claim statement given in the question, whatever is being claimed, that becomes null. If your question doesn't have any claim statement or it is not clear what exactly we are trying to test, then always a simple thumb rule you can follow. Whatever you wish to prove, opposite of that will be null. We use this for regression, for correlation. We wish to prove whether correlation is strong or not. So my null is correlation is 0, weak. So whenever you are confused, there's no claim. null will always be a statement opposite of what you wish to prove. The statistical reason behind that is simple. The idea of hypothesis was created in statistics to disprove theories. The idea was any theory which you could not disprove would automatically be accepted as a valid theory. So that is why statistically you will always observe that null is opposite of what you wish to prove. The idea was if I come up with a new idea, now it is up to the experts to disprove the idea. If all the experts fail to disprove it, it means my idea is correct. That is the reason why if there is no claim, then null in your questions also, in your examples also, you would have noticed null is opposite of what you want to prove. So that is why you have null in the opposite structure, and that would be followed for one tail test also. Now, apart from knowing null and alternate, you can test it using confidence interval. Confidence interval would be constructed in the same manner as the formulas we've written. How do you decide? If if hypothesized value is within confidence interval, then null is correct. So we construct the interval using the data that we collect, and then we check whether the claimed value is within the data or not. Then we have an approach of test statistic. For test statistic approach, if test statistic is beyond Z or T critical range. So whatever range you get from Z or T table, if your test statistic is exceeding that, these would always be plus and minus because these are symmetrical distributions. So when you get the table and you get a value 1.96, it is plus 1.96 minus 1.96. So if your test statistic is less than minus or more than plus, it means it is beyond the range. If it is beyond the range, then null is incorrect. All right. Be careful. You want it to be within the range, right? Now, these are methods of performing the test for single mean. Single mean will always have a claim statement similar to this, some constant value. So returns, this mu symbol is often used for population returns. Some claim would be made on population returns equal to 8%, 10%, 20%, something. So some numerical constant value. Now, apart from this, type 1 error and type 2 error. This should be clear meaning wise for interpretation. Rejecting a true hypothesis, something which is logically true, but you end up rejecting it due to data, that is a type 1 error. And failing to reject a false hypothesis, something which is illogical, but somehow data is showing some relation. So you ended up accepting that relation, that is called type 2 error. And apart from this, power of test. Power of test is simply the ability to correctly avoid type 2 error, because from financial perspective, type 1 error is you losing some possible returns. Rejecting a true hypothesis means you don't invest in securities where you should have invested. So you will miss out on returns. But type 2 error is failing to reject a false hypothesis. So type 2 error investment wise would mean that you end up investing money in some securities where you should not have invested. So that will create extra risk. Risk is always a bigger factor in financial decision making than returns would be. So for that reason, power of test, how well my entire testing process is working, it will be purely based on the ability to avoid the type 2 error. The chances of making type 1 error is called level of significance. All right. Second half of hypothesis test are all the other types of tests. The first here is test of two means, where the claim would be that returns of two different securities are equal to one another. Two securities are performing similar to one another. So over here, test statistic will be given to you. And for all of these approaches, you will always use the test statistic system. So test statistic would be given to you. You will use T distribution to check whether the test statistic is within the range or outside the range as per T table. Then we have test of single variance. Here also, test statistic will be given. You will use chi-square distribution. In chi-square distribution, you have to be careful. It is a type of log normal distribution because it is asymmetrical. So you will have to calculate both the points. In Z and T, you look at the table, you find out one point and you apply a plus minus symbol. So if it's plus 1.96, the other side would be minus because of symmetry. But in chi-square distribution or any other log normal distribution, you no longer have symmetry. So now you have to calculate both the points of critical range yourself from the table. So one will be alpha by 2 and the other will be 100% minus alpha by 2. Then we have test of two variances, where I am making a claim on the risk of two securities. Over here, test statistic will be calculated as variance of x upon variance of y, where the logic is numerator always has to be greater than denominator. Due to this, only higher critical value is relevant. So on the graph, critical value would be lower and higher. Because of this assumption, you never need to bother with the lower half. So your tables will only tell you the higher critical value. And over here, we always use F distribution. For F distribution, you need degrees of freedom for numerator and denominator. For that reason, even though question may often give you the value of test statistic, you should still know what is numerator, what is denominator. And for that, this rule will be used. Whichever risk is higher, that data is assumed to be the numerator. Apart from this, lastly, we had test of correlation. So for test of correlation, firstly, the null statement is structured as correlation equals to 0, statistical insignificance. Why? Because if there is no claim statement, we always make null opposite of what we wish to prove. So if I want to check whether correlation is strong, my null will be correlation is weak. If I can prove that it is weak, problem solved. And if I can't prove it is weak, then I will have to conclude correlation is strong. Now from here, test statistic formula. This is R into n minus 2 upon 1 minus r square root. And here you will use T distribution, but T distribution will have degrees of freedom n minus. So just for the test of correlation in your entire syllabus, degrees of freedom n minus 2. Rest of the syllabus, degrees of freedom is always n minus 1. Last topic of quants is regression. For regression, the entire chapter study is split into four parts rather. First is your basic introduction, where we look at the meaning of regression. We understand the concept line of best fit, and we look at the equation. y is equal to b0 plus b1 x. Alright, some books will use the notation A and B. Some books will use B0, B1. The idea is this is intercept. This is calculated as B1, sorry, y bar minus B1 x bar. Because the assumption is that mean of x, mean of y will always lie on the line of best fit. It will always lie on the regression line. So if these points are lying on the regression line, they should also satisfy the equation. And B1 is slope coefficient. This is calculated as covariance of x and y upon variance of x. So variance of independent variable. Now using all of this, you can predict the value of y. The predicted value of y is called y hat. So if you plug in all the values in the equation, the value of y you get, that is called the predicted value. Now mostly we are dealing with continuous set of data. So what ends up happening is in continuous data, a single value of prediction may not be very relevant. If I'm talking about a stock price and I predict the price of some company will be exactly 2000, the chances of it being exactly 2000 are almost zero, because it can be 1999.99. It is not equal to 2000. It can be 2000.01. That is also not equal to 2000. So you don't give prediction as a single point, you give prediction as a range. So here you can create a range of prediction using T critical value and standard error of estimate. This will come up later on. Then, second part of our discussion is regression table. I want to always be able to check if my independent variable is actually good to study the dependent variable. Is the independent variable actually contributing significantly to the movement or to the changes which are happening in dependent variable? Now for this, the only value that I need to perform or test on is slope coefficient, because the idea is if slope is 0, change of x will not affect change of y. And if slope is something other than 0, then whenever x changes, there will be some impact on y. So for regression table, the hypothesis is always that slope is 0. Slope is statistically insignificant. If you disprove the hypothesis, you prove that slope is relevant, x is relevant in predicting y. So for regression table, you have table with intercept and x variable. Firstly, you have the coefficients given, which is the value of B0 and B1 itself. So when you run the regression in Excel, coefficients will tell you the value of B0, B1. Then you have standard errors given. Then you have test statistic given. Test statistic can be calculated also by coefficients divided by standard error. So if you do B0 divided by its standard error, you get test statistic. And if you do B1 divided by its standard error, you get t-stat value. And lastly, you have p-value. P-value either given or not given. There's no way for us to calculate. It's a hit and trial calculation. So only statistical softwares can do it. In this table, 3 tests can be performed. 3 alternative ways of testing can be done. So first alternative is confidence interval, where you calculate B1 plus minus T critical into standard error. And then check if 0 is within the interval or not. If it is, then null is correct. If it is not, then null is not correct. Second approach is test statistic, calculated as B1 upon standard error. So over here also rule is simple. Is it within T critical range? If yes, then null is correct, otherwise it's not, and null is always defined to be statistical insignificance. And third is p-value. P-value is the smallest alpha needed to reject a hypothesis. So over here, rule is simple. If p-value is less than alpha, level of significance, then null is incorrect. So we want p-value to be as low as possible for me to conclude that my result, my assessment is statistically significant. Then we move to ANOVA table. ANOVA table, this is critical for checking the entire regression model as a whole. At level 1, our chapter's name is linear regression, which means you have one independent variable and one dependent variable. So often the results you get from regression table and ANOVA table will be identical, because whether you study this independent variable or you study the entire model, one and the same thing. The significance of why you have two tables will be more relevant at CFA level 2, where you can have more than one independent variables. So over there, regression table helps me to study the variable one at a time, and ANOVA table helps me to study the entire model together, all variables taken together. ANOVA table, for this also the format of table is relevant. So we have regression and residual. We start with degrees of freedom. This is 1, this is n minus 2, some will be n minus 1. 1 because over here degrees of freedom is supposed to be the number of independent variables. At level 1, this will always be 1. Then you have sum of squared deviations, mean of squared deviations, and finally the F distributions test statistic value. From all of this data, you can calculate R square, which is regression sum of squares divided by total sum of squares. And then we can calculate standard error of estimate, which is mean square of errors. Error is another name for residual root. This is what we use over here to predict the range of dependent variable. Now, ANOVA table, apart from these two calculations, you should be able to fill in the table in case some values are blacked out. You can get a basic question like that also, where a table is given with some values missing, and they simply ask you to calculate those missing values. Apart from all of this, we had one extra discussion, which was the assumptions. The assumptions of linear regression. First assumption is relation is linear. If the relation between variables is not linear by default, and you still wish to use the regression, then we have to change the model specification. This is where we covered different types of models: log linear model, linear log model, then second assumption is errors unrelated with independent variable. So we don't want a situation where error is basically this residual. By nature, this residual or error is supposed to represent unexplained variation. The logic says that whatever I'm taking as independent variable is giving me reasons for some movement of dependent variable. But there will be other factors also that I have not included in my model. Those are supposed to remain unexplained for the purpose of regression to work. If you know why error is happening, then you can no longer call it an error. So the problem is, if your errors can be predicted, then your model is based on the idea that risk, future uncertainty can be predicted in advance. So it will work mathematically, but then when you apply the results of the model in real world has risk. So problem will be you're operating a model which has zero risk because errors can be predicted. But in real world, errors are unpredictable. So your model will fail when you apply it in the real world. This, if violated, creates a problem, heteroscedasticity. Then we covered third assumption, errors should be unrelated with past errors. Once again, the idea is errors should be completely random, unexplained. So if my error of one time period is being explained by previous time period's error, so let's say last day, whatever the error was, is allowing me to predict what the error will be the next day. Then also we reach the same issue that error is no longer random. I can predict it. So it will make my model unreliable. This is called serial correlation. At CFA level 1, you don't need to worry too much about what happens if there is a violation, how to fix it, because all of that is part of your level 2 study. At level 1, you just need an understanding of what the assumption is, why is it relevant, and if a violation happens, then how it makes the results unreliable. That's it. Fourth and final assumption is that errors are normally distributed. This is the reason why we are able to use t-distribution freely without any restrictions. Because we assume that the data is normally distributed. Whenever this assumption is there, we are able to use t-table without any restrictions. Her standard error of forecast is this. That's just a different name for standard error of estimate. Any doubts, let me know. Nimit, contingency table is just a representation of data which has multiple factors. So it is a probability table. The way Institute has explained it, you don't need to go into that much complexity. At basic level, contingency table, let's see. So let's say we have some candidates. Let's say male candidates, female candidates for the exam. And we have classification as per age also. So those who are in the age bracket 20 to 25, 25 to 30, and 30 or above. So idea of contingency table is I'm basically representing my data across classifications. For a moment, don't view it as a table. View it like a graph. So you would have total on either sides. When you view it as a table, it looks like a new concept. But out of all the candidates, you can have candidates who are male, female. Male can be in the age group 20 to 25, 25 to 30, 30 plus. Female can also be 20 to 25, 25 to 30, 30 plus. This and this exactly same. This is just a tabular representation. This is a graphical, a tree diagram. So contingency table is just a way to represent in a tabular manner data which has multiple levels of classification. So this, you can look at this and understand this is also clustered sampling, where my original population is split into two, and further these two classifications also have subcategories. So based on the value of total, you can calculate probabilities. So if I say what is the chance that candidates who clear the exam in the age group 25 to 30, how many of them are going to be female candidates? So in that case, you're looking at this data and comparing it with the total, because your population is now supposed to be this age group. So based on the phrasing of the question, you should then be able to calculate the probability. All right then. So that wraps up our discussion for quants.